Hello. For critical embedded systems, either standards mandate that functional specifications are based on textual requirements, or the latter are part of the contractual agreement. Therefore, it is imperative that what we write is what we mean, with no ambiguities, omissions, or errors. Requirements management tools bring traceability and versioning capabilities, and MBSE tools help capture the architecture and the use cases of complex systems. However, despite this, most errors are introduced during the specification phase, when writing the requirements, and very few of these errors are discovered at this time, generating rework, delays, and additional costs. Why are we in this position? Progress in systems engineering has been made with the advent of simulation to validate embedded systems. These techniques, in the loop, are available at every step of the development: hardware in the loop, software in the loop, and model in the loop. Only the specification phase has not yet had the benefit of simulation because the implementation model details are replaced with textual requirements. As a consequence, the global system could not be simulated, and no tool was able to find the errors and inconsistencies within the requirements or between the requirements and the models. ArgoSim's Stimulus tool reconciles the world of the model and the world of textual requirements, providing an earlier step for the use of simulation. Textual requirements are part of the specification and the whole can be simulated. They are in the loop. Stimulus allows the description of the architecture and the interfaces via a hierarchy of block diagrams. The expected behavior of each of the blocks is described with textual requirements using customizable and executable templates. The language can be freely expanded. The architect may sometimes prefer to describe the expected behavior with a hierarchical state machine or with a mix of textual requirements and state machines. To guide the simulation and explore particular use cases, you can constrain the inputs via a mix of textual constraints and state machines. One use case can generate as many test vectors as you like. In this simulation, we run the specifications of all the blocks contained in the block diagram. We observe the variation of some signals to ensure that the specification is correct. We also validate the detailed specifications contained in the block diagram are consistent with the system-level specification embedded in an observer. Here, the observer is green, indicating that the detailed specification complies with the system specification. This other simulation reveals the conflict between requirements, which has been automatically detected by Stimulus. When a sufficient level of confidence is achieved, the specification can be used for development. Once a design model or some code has been developed, it can be tested automatically in Stimulus. Simply drag and drop the compiled code or an FMU instead of the specification and use the latter as an observer. Here we have a second observer containing a safety requirement. The execution of the code shows a violation of the specification. The safety requirement is respected. Stimulus highlights the reason for the error and identifies the requirement or the part of the requirement that has been violated. Test Stimulus.